This is an example on calculating the moment of a force around a particular point, or the work done by a force in moving an object from one point to another. So the question is, a force F has magnitude 88 newtons and acts in the direction of the vector minus 2i plus 6j minus 2k. And we find the work done by this force in moving a particle from 243 to minus 1 minus 26, and then if the force acts at the point 601, find the moment of the force about the point 3 minus 1 minus 1. So we start off by finding the force itself. So it has magnitude 88 and it has the direction of that vector. I'll call it A, and that's minus 2, 6, minus 2 as a row vector. So the magnitude of A is equal to the square root of minus 2 squared plus 6 squared plus minus 2 squared is equal to the square root of 4 plus 36 plus 4 is equal to the square root of 44. We can simplify that down to be square root 4 times square root 11 is equal to 2 times the square root of 11. Now to get F, I'm going to divide that vector by its own magnitude to get a unit vector, and then multiply by the magnitude of F to get a vector with the right magnitude and direction for F. So that's going to be the magnitude of F divided by the magnitude of A times A itself. So that's equal to 88 divided by 2 root 11 times minus 2, 6, minus 2. And I can simplify down that bit on the left. 88 divided by 2 is 44. 44 is 4 times 11. So I simplify this down as 4 times 11 divided by the square root of 11 times that vector. And finally 11 divided by root 11 is just root 11. So I have 4 square root 11 times this vector, minus 2, 6, minus 2. And that is my force vector. I could multiply in that 4 times root 11 in there if I want to, but I won't do it just yet. So I have my force vector. Now to calculate the work done, I also need the displacement vector. That's S. So it moved from the point 243 to the point minus 126. So to get the vector that joins those 2 points, we subtract one from the other. So I have minus 1, minus 2 will be my first element, then minus 2, minus 4, and then 6, minus 3. So my displacement vector is going to be minus 3, minus 6, 3. And then the work done is the dot product of the force and the displacement. Work is F dot S. So that's equal to, that 4 times root 11 will come out in front, and then it's going to be minus 2, the first element of F, times minus 3, the first element of S, and so on, plus 6 times minus 6, plus 3 times minus 2. That's equal to 4 times root 11 times 6 minus 36 minus 6. So overall that's going to be minus 36 times 4 times root 11 is equals minus 144 root 11. If you like, that's equal to minus 477.59. So that's part A done. That's the work. The next part is calculate the moment of a force if it's applied at the given point around the other given point. So here's the second part. If the force acts at the point 601, find the moment about the point 3 minus 1 minus 1. So I'll write down F again first. So we knew that was, I'll write it down element by element this time. When I multiply it out, I get minus 4 times square root of 11, 12 times square root of 11, and 4 root 11. So I won't bother putting in a decimal for root 11 yet. But when I multiply in that term in front of F into each element, that's what I get. So the moment is equal to R cross F. So I need to know R. R is the vector that joins the point that the force acts around, the fulcrum, with the point where the force is actually acting. So r is equal to, I'm just going to take one from the other to get the vector that joins them. So that's going to be 6 minus 3 is the first element, then 0 minus minus 1, and then 1 minus minus 1. So r is going to be 3, 1, 2. Now the formula for r cross f, you can get it in the notes for a cross b, but it's going to be r2 times f3, so that's the second element of r and the third element of f, minus r3 f2, that's the first element of the cross product, which is a vector. Then it's r3 f1 minus r1 f3, and then r1 f2 minus r2 f1. One way to remember this is that it's going to be the determinant of this matrix. If I put my I, j, k up top, and that, well, in this case it's r, so r1, r2, r3, f1, f2, f3. If you expand that determinant along the first row, you'll actually get that formula. So now I just pop in my numbers. So r2 times f3. So r2, first of all, that's the second element of r, so it's here. So that's 1. f3 is the third element of f, it's here. So that is 4 times the square root of 11. And so on. Next we have r3 times f2. So r3 is 2 and f2 is 12 times root 11. So that's my first element of the cross product. Now I have r3 times f1. So that's equal to 2 times minus 4 root 11 minus r1 times f3. r1 is 3 and f3 is 4 times square root of 11. Last we have r1 times f2, so r1 is 3, f2 is 12 root 11, r2 is equal to 1, and f1 is minus 4 times the square root of 11. So now I just tidy all that up, and I get the square root of 11 times 4 minus 24. I get root 11 times minus 8 minus 12. And I get root 11 times 36 minus 12. So I fix it up again. I get minus 20 root 11. Again I get minus 20 root 11. And I get 24 root 11. And if I want, I can take out a constant in front there of 4 times the square root of 11. And then that becomes minus 5, and 6 inside. So that then is my cross product, and that vector then is the answer to the question. Or I could have, inside the vector, just calculated numerical values for those three, in which case I get minus 66.33 and 79.60. So that's another way of writing down that answer to 2 decimal places. So there it is. Part A and B done.